Alright folks, anaerobic digestion. Does anybody know what that is? No one? Okay, well that's why I'm here. Anaerobic digestion is the process used by anaerobic bacteria to make energy, or ATP, adenosine triphosphate. Write that down. But there's a catch. All of this method is completed in the absence of oxygen. In the 1800s, scientists discovered that this process could be applied to generate methane gas, also called biogas, a flammable gas that can be used for generating electricity and producing heat. Whereas most organisms have converted to getting their energy aerobically in the presence of oxygen, both processes, anaerobic and aerobic, depend on the one same main ingredient, glucose. The only difference is how this glucose is processed. In the aerobic process, glucose is broken down into pyruvic acid and then into molecules called ATP. And in the anaerobic process, glucose is broken down into molecules of methane and carbon dioxide, both equal ATP. The simplified chemical equation representing what happens in an anaerobic process when glucose dissolved. C6H12O6 glucose into 3 CO2 carbon dioxide plus 3 CH4 methane plus 2 ATP energy ATP. There's 4 steps. First step, hydrolysis. The particulates, or sludge, consisting of large polymers, a compound of high molecular weight, are converted into simpler monomers, molecule of low molecular weight. In other words, the complicated polymer structures in the matter, like cellulose or starch, are broken down into simpler molecules like glucose, amino acids, and fatty acids. Once broken down, these monomers start the next step. Acetogenesis. Acetogenesis. It's important, remember the D. The monomers are converted into volatile fatty acids, i.e. C2, C4, H2, and acetic acid, or C2H4O2. Volatile fatty acids are similar to fatty acids, but contain 2 to 4 carbons in their carbon chains. Now the third step, acetogenesis. So you gotta remember, second step, acetogenesis, third step, acetogenesis. The volatile fatty acids, third step, acetogenesis, which are created through fermentation, are converted into acetic acid, H2 and CO2. The fourth and final step, methanogenesis. The methanogenic bacteria consume the hydrogen to convert the acetic acid into methane, CH4, and carbon dioxide, CO2. This can be demonstrated in this chemical equation. 4CH3COOH into 4CO2 plus 2H2. We got those 4 steps. Remember them? Hydrolysis, acetogenesis, and methanogenesis.